Okay, today's video lesson is on oxidation reduction reactions. In this video lesson, what I'm going to do is I'm going to specifically talk about single replacement reactions, which is a type of oxidation reduction reaction. The idea behind all of these types of reactions, don't forget, is the fact that electrons are being transferred. Okay, so you're going to have the charges on these elements are going to change. All right, so a single replacement reaction is somewhat like a double replacement in that we're going to have two things that are going to react, and one element is going to replace another one in a compound. So here, what we're going to have in a single replacement reaction, the way you're going to identify these is that you'll always have an element reacting with a compound, and this compound is almost always going to be aqueous. So single element reacting with a compound. Okay, typically what we have is a metal replacing a cation in an ionic compound. We like to say metal replaces metal. Technically that's kind of wrong because here's a metal. Okay, let me show you an example of what I'm talking about. Let me write this out. An example of this would be something like copper solid. Okay, so that would be my element. Okay, so we'd have a piece of copper metal, copper wire, and what I'm going to do is put that into a solution of silver nitrate. Okay, now technically this is not silver metal, this is a silver ion, which is going to be very different from silver metal you're going to see in a second. So you would have a solution that has silver ions floating in it, that's that aqueous, with nitrate ions in there. And what I'm going to do is I'm going to drop copper solid into that solution. And when I do that, what will happen is I'm going to get copper nitrate to form in solution, and it's going to, so what happens is that copper is kind of like replacing the silver in solution, and this will now become aqueous. So my copper metal is going to change. It's going to go from solid copper metal to now something that dissolves in water. Now you should know that copper metal itself won't dissolve in water if I put it in here. So there's going to be a chemical reaction between the copper and the silver nitrate. And what happens is I'm going to end up with silver solid at the end. So we'll get some silver metal. Now again, silver metal does not dissolve in water, so my point here is that these ions in solution are very different from our metals over here. And we talk about the charges, don't forget that the charges here on the metals by themselves are 0, and over here the charge would be 0. Silver has a +1 charge, copper now has a +2 charge. So there's a change in the oxidation, well, the charges, okay, the change in the charge there. Okay, so that's the general type of single replacement reaction. A single compound is, I'm sorry, single element is going to replace an element in a compound. Okay. All right. So let's take a look at the other types of reactions we'll have. Alright, so the types of single replacement reactions we're going to look at are metals replacing cations, or metals replacing metals, nonmetals replacing anions, which are nonmetals replacing nonmetals, metals replacing hydrogen ions, and metals replacing hydrogen in water. Okay, so here's an example of a type of reaction. So the first thing I'm going to look at is identify this as single replacement because I have a single element in a compound. Okay, that's how I know this is a single replacement reaction. So I have a magnesium is a metal, so it's going to try to replace the cation, or the metal in our ionic compound. Now how do I know if it's going to work? Well, I have to use something called the activity series. The activity series is what we use to figure out if single replacement reactions work. So at the top of our system, or at the top of our series is the most active metal. Okay, so the metal at the top replaces everything below it. Okay, replaces elements below. Okay, so elements that are at the bottom of it cannot replace the ones above it. So lithium replaces everything. Sodium replaces everything below it. Gold cannot replace everything. Okay, so if I look at this reaction of magnesium solid reacting with the zinc nitrate, what I want to do is I want to see if the reaction will happen. So what I'm going to compare is I'm going to compare zinc and I'm going to compare the magnesium. Alright, so magnesium is here, zinc is here, so magnesium is above zinc, so therefore it replaces the elements below. So magnesium can replace aluminum all the way down to gold. So therefore magnesium can replace zinc. So I would write magnesium taking the place of the zinc. This becomes the nitrate. This is now aqueous, and I would have solid zinc coming out of solution. Okay, and there's my reaction. And then, of course, you'd go back and balance it. All right, so let's take a look at the next one. Magnesium is going to attempt to replace the silver. Okay, so magnesium is here, silver is below it, so therefore that reaction would happen. So I would write magnesium nitrate, just like I did for the last one. Aqueous, and I would also fill in here silver solid. Okay, these are always going to be solid because they're going to be metals coming out of solution. All right, so I go back and balance this. I'd have to put a 2 here and a 2 here to make sure that this is balanced. All right, the last one, magnesium is going to attempt to replace the metal or the cation, which would be lithium. Okay, so when I look at that, magnesium is below the lithium, so therefore magnesium cannot replace the lithium. So this would be no reaction. Okay, so metals below the other metal cannot replace it. Okay, so that's pretty much metals and metal replacing cations. The other type is nonmetals replacing anions. In this case, nonmetals replacing nonmetals. Notice that I have two activity series, one for metals and one for nonmetals. All right, so if I'm going to look at a reaction of fluorine, again, I have a single substance here, single substance, fluorine reacting with an ionic compound, is going to attempt to replace the nonmetal. And in this case, it would be chlorine. Okay, this is the most missed question, by the way. A lot of students have trouble with nonmetals replacing anions, but just, when you're finished, I'll kind of explain what how you can check this. So fluorine is going to attempt to replace chlorine. Well, I only have really 4 elements to work with here: fluorine, chlorine, bromine, and iodine. Fluorine replaces everything. So just like with the metals, the top element is going to replace everything below it. So fluorine is going to come in here and attempt to replace chlorine. According to this, it can. So it takes its place. So fluorine's here and chlorine comes out. Now these are going to come out as a gas because they're nonmetals. They're on the right side of the table and they tend to be gases. All right, so chlorine is going to come in here and attempt to replace iodine. Okay, so nonmetal replaces the nonmetal. So chlorine is above iodine, so therefore it works. So I'm going to write ammonium. I don't like the red too much, but let's get rid of that and change it to black. Okay, so we would have ammonium, and that would be chloride, balance the charges. And that's what I was saying earlier. If I go to balance the charges and I replace chlorine with the ammonium, or if I replace fluorine with sodium, wouldn't I have fluorine and chlorine together? And those are 2 minus. That's not going to happen, right? Because I'm going to replace the nonmetal. I want a positive and a negative, a positive and a negative. Okay, fluorines make a -1, chlorines make a -1. They're not going to go together in that compound. And then I would end up with iodine. Now, technically, iodine is a solid if you look at the periodic table, but if you put a solid or a liquid or gas, it's fine. I'm more concerned that you see that the 2 comes out. And of course, you have to go back and balance these. I kind of left that open. I didn't really balance them, but you can go back and do that. Okay. So now bromine is going to come in here and attempt to replace fluorine. Bromine is below the fluorine, so therefore, again, no reaction. So it's pretty much the same thing that we just saw. Okay, so no reaction. All right, 2 more types of reactions to look at. One would be metals can sometimes replace the hydrogen ion in acids. Okay, so some metals can replace hydrogen ions in acids. Now, the periodic table you guys have is already marked, but notice that I have in here hydrogen as if it were a metal. It's really not a metal, but it's on this chart for this reason alone. So everything from here to here can replace hydrogen in an acid. That would go for this rule here. So lithium would replace the hydrogen in acid, barium, zinc, all of them. Okay, so if I had a reaction like zinc solid is reacting with HCl aqueous, okay, zinc is going to attempt to replace the cation, right? Metals replace cations. That's why it's a better rule than metals replace metals. But anyway, zinc replaces the hydrogen. Can it do that? Well, zinc is above it, so therefore it can. So therefore we get zinc chloride, which is aqueous, and we end up with hydrogen. Now remember, hydrogen is diatomic, and it's a gas. and therefore we would have hydrogen gas coming out. So the hydrogen ion turns into hydrogen gas. Okay, and again, you'd put a 2 here to balance that to make sure everything is good. Okay, so any of those metals will do a replacing of hydrogen in an acid. Okay, the last type of reaction is that metals can also replace the hydrogen in water. Notice it's not a hydrogen ion because we're not talking about ions in water, because water is made up of H2O. It's a molecule. There's no ions in there. So some metals can do this. Which ones can do that? That would be your lithium down to magnesium. So these guys here, lithium down to magnesium, can replace the hydrogen in water. Now, magnesium, let's do cesium, solid, reacts with water. Now, this is another reason why I like to write water as HOH. It's a liquid. So if cesium is going to react with water, you would think of this, it's not really, but you can kind of pretend that this isn't a hydrogen ion and a hydroxide ion. Therefore, the cesium would replace your hydrogen itself. So you would end up with cesium and OH, aqueous, and again you would get hydrogen gas to come out of the reaction. Okay, so cesium replacing, this is where you're getting that strong base. Remember, bases have OH in them, and this is considered a strong base that you get right here. Okay, and again, go back and balance. Which ones can do that? Lithium down to magnesium. Now, the periodic table that you guys have with the activity series is marked, so you will have these two areas marked so that you'll know which ones replace the metals and which ones replace the hydrogen ions in water and in the acid. Okay. So what are some differences between double replacement and single replacement reactions? Here's a list. You can pause this and kind of write this down if you want, kind of telling you the difference between them. You can see the basic format is a little different. Solubility rules are for double replacement. Single replacement will use the activity series. Here we're removing ions from solution by forming a precipitate or forming water. Down here we have the transfer of electrons for a single replacement reaction. So let's take a look at one last thing. I'm not going to do all these reactions. We'll definitely do more in class, but I just want to show you one way that you'll see these reactions. Now, what I'm doing here is, because some of these ions have multiple charges, I have to put parentheses around here and tell you what the charge is on chromium. Let me show you what I'm talking about. So I have chromium solid reacting with silver nitrate. Okay. First thing I want to do is I want to see, does the chromium have the capability of replacing it? Well, what I need to do is I need to consult my solubility chart. Here's my my activity series. I'm looking for chromium. Chromium is here. Silver is down here, so it most definitely will do that. Okay, so I know that this reaction works. So since I know this reaction works, I'm going to go ahead and write chromium. But wait a minute, it's a multiple charged ion. Which ion do I use? That's what I'm telling you here. Use the chromium 2 ion. So therefore, nitrate, balance the formula, 2, aqueous, and then I would have silver solid coming out. Now, in the textbook, they won't do this. So if you don't know which ion to use, choose whichever one you want. Okay. So for me, on my tests and quizzes and stuff that I give you, I will specifically tell you which ion to use in the products. Okay. All right. So you can do the same thing for this one here. You can look at whether lead can replace nickel. Here we got calcium replacing water. I would probably rewrite that as HOH and then do that problem. Again, I'm not going to do these. I think you get the idea. If you need to rewatch some things of the video, go ahead and do that. But in class, we'll look at a whole bunch of problems, and I'll answer all your questions in class. So, thanks a lot.